The world of Jupiter is coming into clearer focus for scientists, as new data from NASA reveals how the planet's fluids churn and mingle, both on the surface and deep within the interior. All of these chaotic movements are revealing that Jupiter is even more complex than expected. One surprise is that the winds that flow on Jupiter's surface actually extend deep into the planet's interior, causing strange variations in the world's gravitational field, researchers have found. Even deeper down inside the planet, a gaseous core rotates as if it were a solid, rigid body. Meanwhile, on the surface, gigantic cyclones dot the poles, where they form strange flower-like patterns, though scientists don't know how exactly. The winds that flow on Jupiter's surface actually extend deep into the planet's interior. These new details, reported today in 4 Nature papers, come from NASA's Juno spacecraft, which has been orbiting Jupiter since mid-2016. Juno is in a highly elliptical orbit, a path that takes the probe up close to Jupiter's surface once every 53 days. It's during these close passes that Juno gets within 2,600 miles of Jupiter's cloud tops, allowing its instruments to collect data more closely than any other spacecraft before. We've never been so close to this giant planet before, with an orbiter. Tristan Guillot, a planetary scientist at the University of Côte d'Azur in France, and a lead author of one of the papers, tells The Verge, and although it's going really fast, it's still able to make these precise measurements. Here are some of the biggest discoveries. Winds run deep. Juno has been studying Jupiter's gravitational field, or how far the planet's gravitational influence extends out into space. Now, the probe has revealed that the planet's gravity isn't uniform throughout. In fact, it's unexpectedly asymmetric. Jupiter is basically a giant ball of fluid gas, and researchers thought that it would all mostly rotate at the same rate. If that were the case, the gravitational field would be more or less symmetric. The north and south should be the same globally, Guillot says. So the fact we detect these differences in the north and south gravity field meant there is something different in the two hemispheres. Guess RC equals https://cdn.box/upload/chorus_asset/file/103769115/still_image_1_o.jpg alt equals greater than. That something is deep winds. According to one of the Nature papers, Jupiter has bands of wind and jet streams that crisscross along the surface of the planet and rotate at different speeds, sometimes differing up to 220 miles per hour, 100 meters per second. Many thought these streams might just exist on the planet's exterior, a bit like the winds on Earth. But now, researchers think the jet streams actually stretch deep within the planet, about 1,800 miles, or 3,000 kilometers, downward, according to models. The deep jet streams would actually change how parts of the planet's interior rotate. And since the winds are different in the northern and southern hemispheres, it explains why the gravitational fields are different for each half of the planet. Now we know definitively that the surface winds do go quite deep, and what we're actually seeing is how fluids move in the interior, says Jonathan Fortney, a planetary scientist at the University of California at Santa Cruz, who was not involved in this research but reviewed the papers for Nature. A fluid core that acts solid. Juno's measurements of Jupiter also indicate something much deeper down than the planet's jet streams, a fluid core that rotates like a solid. Scientists mapped Jupiter's global gravitational field and then used that information to model the interior of the planet. Those models suggest that Jupiter's core, which is made of mostly hydrogen and helium, rotates as a rigid body, even though it's all fluid. Jupiter has a huge magnetic field, and it's dragging the flow everywhere. Guillot thinks that may be because the gases inside the core are electrically charged, or ionized. This causes the fluid core to rotate in lockstep with Jupiter's magnetosphere, a large field of magnetism that surrounds the planet and is generated by electrical currents inside Jupiter. The magnetic field manipulates how particles move around Jupiter, and inside as well. Jupiter has a huge magnetic field, and it's dragging the flow everywhere, says Guillot. That's why the deep interior is rotating uniformly. Cyclones circling. Cyclones. Juno has already revealed that cyclones, some as wide as Earth, dot the northern and